You've probably never seen a city that's older than your grandparents, built by creatures smaller than your thumb, and hidden beneath your feet. This is the secret world of ants, engineers of the underground. These tiny architects don't just build nests. They construct sprawling underground metropolises with roads, chambers, and even ventilation systems. They've been doing this for millions of years, long before humans built their first city. But how do they manage to build such intricate structures without blueprints or tools? The answer lies in their incredible collective intelligence, a kind of superorganism that functions as one mind, one body. This is not just about survival. It's about engineering at a scale that challenges our understanding of biology. We're about to dive into the hidden world of ants and their underground cities. So, what exactly are we talking about? These aren't just ants. They're architects of an entire subterranean metropolis, built with precision and purpose. These nests can stretch for meters underground, with rooms for nurseries, food storage, and even specialized chambers for defense and communication. This isn't just survival. It's a sophisticated system of logistics, with trails, signals, and even a form of traffic control to manage the flow of workers. Every structure, every chamber, every tunnel serves a function. This is not just a home, but a living, breathing network of interdependent systems. So when we talk about Nestle Ants' underground city networks, we're looking at a world of hidden complexity, a society built on cooperation, survival, and sheer biological ingenuity. Ants aren't just busy little creatures. They are architects of an invisible world, building cities so complex they rival our own. Their networks are the blueprint for resilient, efficient systems that we can learn from. These underground cities are designed for survival. They're self-sustaining, with waste management, temperature control, and even defense systems, proof that nature has mastered the art of engineering. Their underground networks are also models for sustainable living. By studying their efficiency, we might unlock new ways to build cities that work with nature, not against it. In a world full of challenges, ants remind us that intelligence isn't just in size. Their hidden cities teach us that complexity, resilience, and cooperation can emerge from the smallest of creatures. The ants' underground city networks date back over 100 million years, evolving in tandem with the Earth's shifting landscapes. These ancient tunnels were built not by design, but by the collective intelligence of millions of tiny workers. Throughout the Cretaceous period, these networks expanded alongside dinosaurs, adapting to climate shifts and ecological changes. Some ant species even co-evolved with plants, shaping entire ecosystems below the surface. In the Miocene epoch, these networks became more complex, with specialized chambers for nurseries, food storage, and defense. The ants' social structure refined over millennia, giving rise to the highly organized societies we see today. The speed of their evolution is astonishing. Each new generation improves the network, adding layers of complexity. Their architecture is as ancient as the planet itself, yet constantly growing and adapting. So, when we look at the underground world of ants, we're seeing the living archive of Earth's history, written in soil, stone, and the relentless drive of tiny, invisible builders. Imagine you're a tiny ant, and your home is a big, busy city under the ground. You live with thousands of friends, and everyone has a job. Your city has rooms for sleeping, eating, and even a special place for the queen, who's like the boss of the whole team. You all work together, like a big team, to keep the city safe, warm, and full of food. No one is left out, and everyone knows their part. Even though you're tiny, your city is huge, and it's all built by teamwork, smart planning, and a little bit of magic. The process starts with a single ant, a worker, who scouts the area for a suitable spot to begin the colony. This ant has a precise mission: to find the perfect balance between safety, temperature, and resources. Once a site is chosen, the ant begins to excavate a small tunnel, using its mandibles and legs to move soil away. This first tunnel is the foundation of the entire city structure. As the tunnel expands, the ant leaves behind pheromone trails, marking the path for other workers to follow. These chemical signals are crucial for communication and coordination. The first workers then reinforce the tunnel walls with secretions that harden into a natural mortar, stabilizing the structure and preventing collapse. With the foundation secure, the colony begins to branch out, creating a network of interconnected tunnels that will eventually evolve into a vast, complex underground metropolis. Once the colony is organized, the ants begin to lay down the framework of their city. They use a special secretion to mark trails and structures, creating a kind of living blueprint that guides their building efforts. This secretion acts as a kind of chemical map, helping the workers know where to go and what to build. It's like a digital signal in a biological network, communicating direction and purpose. The workers then use their mandibles to shape the soil into precise chambers and passageways. They work in coordinated teams, each responsible for a specific part of the structure. They also use their bodies to transport soil, linking the chambers together in a seamless, functional layout. Each movement is a calculated part of a larger system. Throughout this process, the colony remains in constant communication, adjusting their efforts based on the needs of the whole. It's a model of collective intelligence in action. Once the worker ants return with the food, they don't just drop it anywhere. Instead, they carry it to specialized chambers deep within the nest where the food is stored and organized, like a kitchen in a giant ant city. These chambers are not just storage spaces. They are also hubs for processing food. Some ants use their mandibles to break down seeds, while others secrete enzymes to extract nutrients, turning raw food into something the colony can use. Once the food is processed, it's passed along to other workers, who carry it to the brood chambers or the queen's chamber, ensuring that the entire colony is nourished and grows strong. This process is so efficient that it allows the ants to sustain their massive underground city without needing to constantly search for new food sources, making their system a marvel of natural engineering. And this is just one part of the system. There's still more to discover about how these ants manage to build, sustain, and thrive in their subterranean world. Beneath our feet, these ants are using chemistry to build their cities. They secrete acids and enzymes that break down soil and create tunnels with incredible precision. Their tunnels are not just hollow spaces. They're engineered with temperature control, humidity regulation, and even air circulation systems that rival human engineering. The ants use a combination of pheromones and sound to communicate across vast distances, creating a kind of ant internet that coordinates the entire colony. Some species even use fungal gardens to produce food, turning their underground cities into self-sustaining ecosystems that thrive in the dark. These are not just ants. They are architects, engineers, and ecologists, all operating in complete silence, but building something that rivals the complexity of human cities. Imagine a city where every street is a tunnel, every building is a chamber, and every citizen is a worker, all moving in perfect rhythm, guided by invisible signals. It's not a city of humans, but of ants. This city is built not by design, but by the collective behavior of millions of tiny minds, each following simple rules, yet creating something far more complex than any single ant could imagine. Like a bustling metropolis, the ant city has its own infrastructure. Roads for traffic, storage units for food, and even specialized zones for different tasks, all operating without a central control. And just like humans, these ants have a system of communication, using chemical trails, vibrations, and even sounds, though they're far more silent than a city full of humans. So, if you're ever lost, remember that even the smallest creatures can build a world that's as complex and wondrous as our own. Just don't try to follow their map. It might lead you to a very busy underground city. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.